Hello everyone, today we are going to study about Osborne Reynolds experiment. This experimental setup allows laminar and turbulent flows to be demonstrated. Coming to the introduction part, the flow behavior basically depends on inertial, viscous, gravitational and surface tension forces. The flow behavior is basically classified into three types, namely laminar, turbulent and transitional flows. In laminar flows, the viscous forces dominate inertial forces, and in turbulent flows, inertial forces dominate viscous forces. To characterize the flow behavior, we use Reynolds number, which is the ratio of inertial and viscous forces. If Reynolds number is less than 2300, then we classify it as laminar flow. If it is between 2300 and 4000, then we classify it as transitional flow, and above 4000, all flows are classified as turbulent flows. This is the schematic diagram of the experimental setup which we are going to use, and this is the exploded view of the actual experimental setup which we have in lab. These are the technical specifications of the experimental setup. Now let's visualize the experimental setup. We have the drainage valve through which extra water is expelled. Then we have this water inflow valve which is used to fill the transparent reservoir via this control valve. Here you can visualize the water filling the reservoir by the movement of the glass balls. The red pipe inside the transparent reservoir serves as overflow section. We have the aluminium reservoir where ink is stored, and this is the metering tap which allows ink to flow through the brass inflow tip. This ink along with the water flows to the test pipe section and then to the drain. We slightly open the metering tap to allow the flow of ink through brass inflow tip. We adjust the drain valve in such a way that the flow rate through the drain pipe is very small. For this we can see the single blue line in the test pipe depicting laminar flow. Then we note the time taken by the discharged water to fill 1 liter flask and note it in the observation table. Now for turbulent flow, the drain valve is opened wider. It produces a high flow. The current thread is broken up in turbulent flow. Here you can see the flow of ink through the test pipe. Now similar to what we did in laminar flow, note down the time taken by discharged water to fill 1 liter flask in the observation table. Also record the temperature of the discharged water after every experiment. This is the observation table where we need to note the readings mentioned before, and these are the formulas which we will be using. Based on the readings and formulas mentioned before, calculate the discharge, velocity and Reynolds number. The kinematic viscosity depends on temperature of the discharged water, which is obtained from heat and mass transfer data book.